Pre-feasibility analysis of energy efficiency measures for buildings and factories with RETScreen Expert. Part 1. Overview of energy efficiency pre-feasibility analysis. In this series of videos, I'll show how RETScreen Expert can be used to evaluate the pre-feasibility or feasibility of a suite of proposed energy efficiency measures applied to a building or industrial facility. These videos will concentrate on the aspects of the analysis that are specific to energy efficiency and are therefore mainly found in the Energy tab. If you are interested in a more general overview of RETScreen's capabilities or detailed guidance on how individual energy efficiency technologies are dealt with in RETScreen, visit the RETScreen e-learning YouTube channel by clicking on its icon at the far right of the home screen under the File tab. Let's say that I'm looking at implementing energy efficiency measures in an industrial plant that fabricates metal parts. This would likely be a fairly complex facility. Setting up a model containing the building and its equipment would be time-consuming. It would be nice if I had an example to start with, an example that I could modify to match the particulars of my plant. Happily, RETScreen Expert can provide such an example from its extensive bank of facility archetypes, accessible through the Virtual Energy Analyzer. To access the archetypes, I click on Virtual Energy Analyzer under the Getting Started Options column in the home page of the File tab. A map opens, allowing me to select the location. I'll drag the project thumbtack to London, Ontario. Then I select the archetype by way of the drop-down lists. I'll pick Industrial for the facility type and Fabricated Metal Products for the type. Once I've done this, I click on the green checkmark button at the bottom right, and RETScreen configures itself with the data from the archetype. I now navigate through this analysis by generally moving left to right through the tabs across the top. The Location tab confirms the location I selected and loads climate data. It is described in other videos. On the Facility tab, I see that the software is set up to do a feasibility analysis of a metal fabrication plant. From the image, it looks like the archetypal plant is a small office space attached to a larger manufacturing area. The benchmark section contains information about how much energy, in the form of fuel, is typically used for all purposes, heating, cooling, lighting, equipment, and plug loads, in these type of plants. The archetypal plant has 95 employees. A benchmark of 68 megawatt hours per employee has been provided. That is squarely in the middle of the range of typical values for such a facility. This range is taken from the benchmark database accessed from the menu bar. Note that these energy intensity figures are on an annual basis. Unless otherwise indicated, in RETScreen, fuel consumption and energy consumption or production are given for the period of a year. Below this, the fuel energy consumed by this archetypal plant is listed for the base case and the proposed case. The base case typically reflects the business as usual option. That is, the current state of the facility, if it is already constructed, or the conventional technology that will be utilized in the case of a planned project. In contrast, the proposed case typically employs more efficient technologies with higher initial costs. RETScreen compares the additional or incremental costs and benefits of the proposed case versus the base case. For this archetype, the base case and proposed case fuel consumption are 3,117 megawatt hours and 2,222 megawatt hours. These values have been set to reflect the current state of the archetype modeled in the Energy tab. Note that I can change these numbers in the benchmark section without in any way affecting what appears under the Energy tab. Conversely, if I make changes under the Energy tab, any resulting change in the base and proposed case fuel consumption will not automatically be reflected in the benchmark section, although there is a feature that synchronizes the two sections. There is a lot going on under the Energy tab. I see that there is data describing various aspects of the metal fabrication plant. I'm going to focus on this tab, but before I do that, I just want to quickly show the other tabs. Under the Cost tab, there are three sections: Across the top, the incremental initial costs show that the equipment in the proposed case costs a little over $1 million more to purchase and install than the equipment in the base case. This is automatically calculated and carried over from the data entered in the Energy tab. The annual cost section shows that the proposed case would cost around $69,000 less per year for operations and maintenance than with the base case. Note that the parentheses around the number indicate that it is a negative cost, that is, a savings. Even in the proposed case, the plant will still consume $175,000 per year in fuel, but that is less than the $252,000 annual fuel bill in the base case. The cost analysis is configured as a Level 1 analysis, which shows a minimum of detail. To enter costs in more detail, I could use Level 2 or 3. A similar level switch exists in the Emission tab and the Finance tab. Under the Emission tab, the difference between the greenhouse gas emissions in the proposed and base cases is found to be 105 tons of CO2 equivalent annually. This includes the emissions from all fuels consumed in the plant, which happen to be natural gas and electricity. An emissions factor of 0.1 tons of CO2 equivalent per megawatt hour of electricity consumed has been drawn from RETScreen's database of average emissions factors for different countries and provinces. On the Finance tab, a Level 2, that is, a detailed analysis of the cash flows, profitability, and quickness of return, is provided. The Risk tab extends this financial analysis to reflect uncertainty in inputs. The impact of variation in pairs of key parameters on the profitability and quickness of return is shown through sensitivity analysis tables across the top of the tab. At the bottom, a risk analysis shows the impact of simultaneous variation in a suite of key input parameters. Finally, in the Report tab, I see that a feasibility report reflecting key findings from the previous tabs has been generated. The Cost, Emissions, Finance, Risk, and Report tabs are essentially the same for all feasibility analyses, so I'll return to the Energy tab where there are elements that are specific to energy efficiency. At the top of the tab, there is a menu ribbon. At the left is a navigation pane, and at the right there is a main screen. Its content changes depending on what element has been selected from the navigation pane. For example, when I click on Electricity and Fuels in the navigation pane, the main screen shows information related to the prices of fuel and electricity. By default, the summary section is shown when the Energy tab is displayed for the first time. Observe that the items appearing from left to right in the menu ribbon also appear, in the same order, but from top to bottom, in the navigation pane. For example, to the right of Electricity and Fuels in the menu ribbon, I find Schedules, which appears just below Electricity and Fuels in the navigation pane. Note that from left to right, the elements of the ribbon are labeled Step 1 through Step 5, and then there are options at the far right. Following Steps 1 through 5 will guide one along the path to assembling an energy efficiency model. If this had not already been done for us when the archetype was constructed, this is what we would do. To conclude this video, I'll introduce each of these steps. In Step 1, Fuels and Schedules, we list the fuels, which can include electricity, available for use in this facility, and their prices. We also specify what the thermostats are set to, when ventilation fans operate, and when the ventilation system draws in fresh air. In Step 2, Equipment, we specify the efficiency of the various equipment that provide heating and cooling. Note that the form for each piece of equipment contains specifications for both the base case and the proposed case. In Step 3, and Use, we specify, for the base case and the proposed case, the elements of the facility that require heating, cooling, or electricity. This could include the envelope itself, lighting, ventilation, motors, pumps, process steam, and many other elements selected from the drop-down list. In Step 4, Optimize Supply, we can model a solar, wind, or other green power system for meeting part or all of the heating or electricity requirements of the facility in the proposed case. That is, RETScreen will try to use any renewable energy systems defined here to meet the heating and electricity requirements stemming from the proposed case elements listed under Step 3, End Use. If the renewable energy system output is less than what is required by the facility, the remainder will be supplied using the heating equipment specified in Step 2, Equipment, or, for electricity loads, the default electricity supply at the price given in Step 1, Fuels and Schedules. In Step 5, Summary, I can view the results of my analysis in two tables. The first, Include Measure, has a row for each of the elements listed in the Equipment, End Use, and Optimize Supply sections. The row summarizes the fuel and energy consumption or savings. It also provides the initial costs, operation and maintenance costs, and fuel costs, and calculates the simple payback of the measure. A checkbox allows us to specify whether the facility model includes the proposed case equipment. If it is not included, then the base case equipment is assumed to be used when calculating the proposed case energy consumption. The second table, Comparison, shows me the total base case and proposed case fuel consumption for each type of fuel, and the savings that arise. It also provides tables for comparing the model output to historical data and to the benchmarks and targets previously defined on the Facility tab. The options at the far right of the ribbon bar provide access to various tools and functionalities. The available options change depending on what section of the Energy tab is open. In the next two videos of this series, I will look in more depth at the 5 steps of the Energy tab.